systematic drawing and description of flake tools. Dear students, in the previous classes we have discussed on the systematic drawing and description of lower Paleolithic core and heavy flake tools such as chopper, chopping tools, piriform type of hand axe, triangular type of hand axe, ovate type of hand axe, U-shaped cleavers and V-shaped cleaver. In this module, we shall discuss on the systematic drawing and description of lighter flake tools, which belong to the Middle Paleolithic cultural phase, particularly the scraper tool type group, and its types, subtypes, and varieties. Let us see what is a scraper. It is a flake tool, sometimes made on blade and on workout cores. It is used for scraping purposes. According to the nature of the working edge, this type is further subdivided into three types, that is side scraper and round scraper. The side scraper has four subtypes, that is straight side scraper, concave side scraper, and convex side scraper, concavo-convex side scraper. And the convex side scraper has two varieties, that is slightly convex side scraper and deeply convex side scraper. Now let's come to the procedure of drawing. For a systematic drawing of a lithic tool, certain procedures are to be followed. Now let's come to the orientation of the given tool. Say, let's see. This is a scraper, and if it is supplied for drawing, then we should examine for placing the scraper. How to place it? We should examine the working tips, because here you find the converging edge, and we should place it on the left side. Then we have to draw first, and then we have to move like this, then we move in this way. This is known as the dorsal view, this is the profile view, and this is the ventral view. Say, if a scraper is selected or supplied for drawing, the working edge should be placed according to the nature or the type or subtype of the scraper. Now let us discuss on the nature of presentation. Say, let us select this tool. This is the convex types of side scraper. We should represent these three-dimensional tool, say having its length and then breadth, then thickness. It should be represented by two-dimensional illustrations, say only length and breadth on the drawing sheet. The boundary should be represented by thick lines. Not only the boundary, the edges also represented by thick lines. And the flake skirts, according to the nature of the flake skirt, it should be represented by, in this case, it should be represented by slightly curved lines. Whereas in another tools like in these tools, these having deep flake skirts, it should be represented by very curved or more curved lines. Whereas these should be drawn by lesser curved lines. And in this case, we have to represent the flake skirt by slightly curved flake skirts. Let's see an example here. This is somewhat in this way and having this, and these are represented by, these are the secondary flake skirts, and this is the primary flake skirt. It is represented by slightly curved lines. And these secondary flex curves are represented by more curved lines and also thick. And these are the boundary lines. It is represented by thick lines. And this is the arises. It also represented by thick lines. And it is somewhat flaying, and it is represented by more straight lines. Whereas in such types of tools, having deep flex curves, it is represented by this is the original pebble surface area, and it is represented by more curved lines, and it's also represented by more curved lines. Yes. Then let's see. Here the flex curve is somewhat shallow, and whereas these flex curves are very deep, and these deep flex curves are represented by the more curved lines, whereas the shallow flex curves are represented by less curved lines. And in case of the somewhat straight area, then it is also represented by somewhat straight lines. And the cortex region is represented by dots. The boundary is represented by thick lines. Like this, it's also represented by thick lines. And not only the boundary, the arises, these are the arises or the elevated areas or the ridges, it also represented by thick lines. For drawing and describing a given specimen systematically, the following instruments and materials are needed. First of all, this is the slide caliper. It is used for measuring the tool, the length of the tool, the breadth of the tool, the thickness of the tool. It is known as slide caliper. The next one is one long scale, at least 30 inches is needed. It is used for drawing the upper and the lower margins of the tool. Then 2 set square is needed for measuring the height and the length of the flex curves and the ridges. Then 1 compass is also needed for drawing or for getting the ridge point. Likewise, this divider is also needed for measuring the length and the breadth of the flex curves. To place the supplied specimen accurately, this model clay or plasticine is highly needed. And to make the ridges more prominent, chalk stick is also needed for drawing the specimen. Last of all, these pencils and erasers are also needed. These are all the needed materials and required instruments for drawing the given specimen systematically. Out of this slide caliper and the lithic tools along with the model clay should be supplied by the department concerned, and the drawing sheet, the compass, the divider, the set square, the long scale should be brought by each student for drawing. Hello students, we have discussed on how to present the lithic tool, means nature of presentation, and the needed materials we have discussed. Now let's come to the technique of drawing. Certain techniques need to be followed for an accurate drawing of the scraper or scrapers. Here we will take up only one subtype of scraper as a technique for drawing the different subtypes of scraper are more or less the same. Number 1. Each student should measure the maximum length of the supply tool along its axis. Secondly, the students should draw two horizontal lines on their respective drawing sheet, forming the proximal and distal boundaries of the supply tool. Number 3. Before starting the accurate drawing, each student should draw an imaginary line across the longitudinal axis of the given tool, which dissects the specimen into two halves horizontally. Number 4. Then the specimen is placed passing one of its horizontal halves parallel to the plane surface of the drawing table. Number 5. To confirm the accurate position of the given tool, each student should draw a line along its axis, that is x-axis, and another line crossing the longitudinal axis along its half length, that is y-axis, and measure the height of each end points falling on the working tip or butt end and two lateral sides. If 3 points out of these 4 end points get similar height, considering the nature of workmanship, it should be considered that the specimen is placed and fixed properly. Otherwise, the position of the artifact should be changed, and the same procedure should be repeated until the specimen is placed and fixed properly. Number 6. If the artifact is placed properly, the next step is fixing the specimen in its proper position by filling the gap using plastic sheet. The 7th point is, after getting the proper position, the specimen is then transferred to the drawing sheet. While transferring, the one hand of the student should hold the artifact with plastic sheet, and the other hand hold one set square already placed affixing to the lower horizontal line already drawn as the lower margin of the specimen. The 8th point, the 7th step to find out the arises and important prominent points which would help each student while drawing the given tool accurately. Hence, each student should take a chalk stick and gently roll over the dorsal surface of the supplied specimen so as the student can mark the prominent points and arises nicely. The 9th point, the 8th step is the drawing of the outline by dots consecutively using a sharp and pointed pencil and a set square. While drawing the outline of the artifact, each student should always remember to mark the end points or starting points of each prominent areas or arises, which will help later the students while drawing the accurate position of the arises of the given tool. The 10th point is, the 9th step is the removal of the lithic tool from the drawing sheet. The tool is then placed properly with the apex plasticine on the practical table again without changing the position already drawn. 11th, the next step is taking the accurate measurement by using either two set square and a divider or a compass and two dihedrons, that is a folded index card or both. 12th, the accurate measurement thus taken is noted on a rough sheet first, then plotted again on the drawing sheet later, but within the already drawn outline illustration of the supply tool. To get an accurate measurement of each point, at least 3 measurements should be taken from 3 marked lateral side end or starting points already plotted or marked on the boundary lines. An arc should be drawn for each measurement to get a fixed point. The point where the 3 arches crosses is considered to be the accurate point, which is the desired point. If the 3 arcs or arches do not cross at the same point, the same procedure should be repeated. In this way, each student can find many desired points. 13th, the 11th step is joining the desired points to represent the arises in between the flex curves by using pencil. 14th, the final step is shading. It is a means of expressing volume and is done with a pencil in light hatching or gray tint. Shading also expresses nature of the flex curves represented by more or less curved lines, striking platforms, broken areas, if any present, cortex region, and the nature of the manufacturing techniques. The same procedure is repeated while drawing the outline and different arises or flex surfaces of the profile view and the ventral view of the tool. The cross-section of the specimen is taken normally at its half length along its longitudinal axis where the maximum thickness is also taken. In this way, all the students of prehistoric archaeology section of anthropology department can easily draw the outline of the tool first. It is followed by sorting out of the desired points and taking measurements. Thus, they can find many points one after another and join them to make the accurate shape of the flex curves and arises present on the surface, that is dorsal, profile, and ventral of the given tool. Dear students, we have discussed how to draw the given lithic tool accurately. And now let's come to how to describe systematically the supplied or drawn specimen. For a systematic description of the given tool, the following points are required to mention. Number 1, museum number, like this. Museum number is written here. We have to mention this museum number or accession number to understand where from the tool is explored or excavated or collected or place where it is housed or exhibited. Number 2. It is normally written on the dorsal surface of a specimen. It should be recorded properly. Number 3. About the raw material. It gives an idea about the basic minerals and the rock types used for shaping the tool as well as mineral outcrop of the particular area. Say suppose in this annex, this is made out of the quartzite. Then we can easily understand area where this tool was manufactured is abundantly found or spread by the quartzite minerals. Next, this is a chalcedony. Then we can easily understand where from it was procured. I mean, the raw material is abundantly found in that area if we have mentioned along with the museum number. Let's come to the measurement. The maximum length of this tool is 9.3. By measuring or using this slide caliper, it is 9.3 along its axis. Then let's come to this maximum braid along its half length is 4.9. And similarly, the thickness, maximum thickness along its half length is 1.6. Before describing the state of preservation of this particular tool, we should examine different types of state of preservation, whether in this case this is slightly rolled and slightly patinated. In this case it is rolled and patinated. Whereas in this case it is heavily rolled and heavily patinated. So while describing these convex types of scraper, it should be described as heavily rolled and heavily patinated about its state of preservation. Now let's come to the general description. The given tool is somewhat semicircular in shape. The dorsal surface is represented by two large primary flexures, and a number of secondary flexures is presented towards the periphery. Now let's come to the profile view. The profile line is wavy and continuous. The ventral surface is represented by a main flexure. There is some evidence of prominent positive bulb of percussion, but this positive bulb of percussion is removed by secondary flexure. Now let's see the cross section. The cross section is somewhat triangular in shape. That means the ventral surface is represented by only one flexure. The dorsal surface is represented by two main flexures. That's why it becomes somewhat triangular in shape. Now let's come to the probable tool marking technique. From the shape and the size of the tool and the nature of the flexures present on the specimen, it might have been prepared or named by using level 1 technique. Now let's come to the probable tool type. From the shape, size and nature of the manufacturing technique, the given specimen is identified as side scraper, but it is of complex types of side scraper. Probable cultural period and chronology. Culturally, this specimen belongs to Middle Paleolithic cultural phase, and chronologically it belongs to Pleistocene time. And now let's come to the probable function and economy. It might have been used for scraping purposes, and it can be easily understood from the shape, size and the nature of the working tool. And economically, it belongs to food gathering and hunting. Now let me come to its conclusion. Prehistoric archaeology is the construction of history of mankind until the written records of the events are available. To understand the cultural history of mankind, all the students of this discipline are trained to draw the lithic tools accurately and describe them systematically. In this module, they are instructed to draw the type group scraper, its types and subtypes.